on this one.
Good day, viewers all over the world. We are welcome to another chemistry series, communication. Today we shall be looking at how to balance the following. We shall be looking at how to balance half reaction, full reaction equations. How to balance half reaction and full reaction equations. Okay? This is also very important for students in SS1, SS2, SS3, students preparing for advanced program and down to the university level. They will find this particular class, this particular STEM communication very interesting. Now we have on the board 3 questions for us to practice. Okay, the first 2 is half reaction, then the other one is full reaction, even though we are still going to split it into 2 and then try to recombine that again. Now, if you look at this, the same normal law of conservation of mass needed to be observed also. You have to check if the atom at the reactant side and the product side for a particular element is balanced, meaning if they are equal. You have to check for the ion, the charges, whether it is also balanced at both sides. So these are the fundamental thing you look out for when you are balancing any chemical equation. Now we have here example 1. We have sodium element are being reduced to sodium ion. Don't forget that this sodium is a metal. Metal are givers. They give. Okay? You understand? They give to their neighbors. So this sodium has given by losing what? 1 hydrogen and 1 electron. That's why it carries positive charge. That positivity shows, oh, it has lost 1 electron. If what you have is +2, it means it has lost 2 electrons. So in this case, this sodium element has lost 1 electron. And the number of electrons or charges an element like metal possess when it is ionized is its combining power. We call it oxidation number. So like the oxidation number of sodium is has increased from 0 to 1. From 0, when it is not ionized, it is 0. When it is ionized, it can be 0. So for metals, it is positive. If it's not metal now, it will be negative. So it means that sodium element lost 1 electron to be ionized. So the oxidation state status has increased from 0 when it carries no charge to +1 when it is not being ionized. And so when you have that happen, we see that sodium element has been reduced because it has lost to be positive. Okay, it has lost to be positive, so it has been reduced from sodium element to sodium ion. So if you look at this, you look at the reactant side and the product side. How many atoms of sodium do we have here? 1. We have 1. So what we just have to balance here is the number of is the charges. So if you look at this side, it's having plus 1. Here is 0. No charges here. Let me just put it there, 0. So to balance, I need to neutralize this. Don't forget that we neutralize charges, or we minimize charges, or we increase charges by introducing electron. So which side will I introduce the electron now for both sides to balance? Is this side plus 1 moles of electron, because +1 minus 1 equals to 0, and we already have this to be equal to 0 here. So that's how to balance that. Very simple. Okay, now if I'm to carry this plus E negative to this side, it will become, look at this, it will become Na, then it will not be minus. Don't forget, just like what as you have it in mathematics, if you carry anything across equality symbol, this arrow is representing equality now. Okay, so if you carry anything across, it turns to negative. So minus E minus, then plus giving us Na plus sodium ion. Now let's see how to balance whether the ion is balanced. This is 0, like I told you the other time. 0. What is this? Minus. This electron carrying -1, that is in bracket -1. Okay, then here, what do you have? This is +1. There's a 1 here that is invisible, +1. So 0 minus 1 minus 1, that is +1 equals to 1. So 0 plus 1 is 1, E is also 1. So the charge is balanced. So take note, it can be like this or like this. It's the same thing. So watch out for that, maybe in an exam or whatever. Okay? Thank you. So we'll go to the second one. I want to clean this. Yeah. So we'll go to the second one. I want to wipe this off to create space for me to be able to handle this first one. The second one. Now if you look at the second one, oxygen is already oxidized at the reactant site. Oxygen is already in ionic form. It's ionized at the reactant site, but it exists as a molecule, as a gas in the product site. Now, if you look at this, the first thing we need to balance here is to balance it atomically so that the law of conservation of mass is obeyed. Okay, so we have one oxygen atom here, we have 2 oxygen atoms here. So if I put 2 here, then atomically the equation is balanced. But in terms of charges, these 2 has affected this -2, the charges ion carries. So it's now 2 times -4, 2 times -2, that's -4. This one has no charge, it's not ionized, that is 0. 1 times 0, so this is 0. Now, how do I neutralize the, because in terms of charges, it must be balanced. That is where the issue is now. So how do you get this balanced? Now, because oxygen is a non-metal, if you look at it before I put this 2 there, the oxidation number has increased from -2 to what? 0. Do you see that? So this one is oxidation. This has been oxidized to oxygen gas. Okay, -2 is smaller compared to 0. So that is oxidation that has just taken place there. So non-metal are being oxidized by doing what? They are oxidized by what? By gaining. How many electrons does oxygen gain to become oxidized? It's 2. It has to gain. They are always receiving. They are the receiving side. So non-metals behave generally like that. So now to balance this now, what do? I need to minus. Let's see if I put minus, how many electrons? 4 moles of electron here. Let's see whether it is balanced. Because the charge is supposed to, in terms of charge, is supposed to be balanced. So this is 2 times -2, that's -4. This is minus, mind you, minus. Then what is how many electrons? We have a 4. 4 times -1. There's a 1 here. Then -4. So this gives us -4. Minus times minus plus 4. What is -4 plus 4? That is 0. So this side is equal to this side. 0 is balanced. Now, just like I told you when we are balancing that sodium element the other time, for non-metals, which oxygen is, you can as well carry this minus to the other side. It will become 2O2 minus, giving you oxygen gas. Okay? This will turn to, don't forget, once you carry anything across equality sign, this arrow sign, it turns to plus. Plus what? 4E minus. Let's say that it is balanced. 2 times -4, that's -4 at the reactant side. This side, no charges, that is 0. This one plus 4 times -1, -4, that's -4. Plus 4 times -1, that's -4. So we have -4 this side, 0 minus 4, that is -4. You can see that it's also balanced. So don't forget, it can either the electrons you have introduced can either be at this side or the other side. All you just need to do is to apply mathematical principle. Now, lastly, we'll go to the last one quickly. Look at it. We want to balance this. Now, to balance this, we have ion element with copper ion giving us 3 iron 3 ion and then copper elements there. Okay, so there are two ways you can do this. The easier one is for you to break it up into two. Ion giving you ion 3 plus. Okay, then this copper ion Cu2 giving us copper elements. Now, so the same process that we have adopted in the first two examples, you adopt it here. In terms of atom, one atom of ion is at once, the other at both sides. One atom of ion, one atom of ion. In terms of charges, what do you have here? This is 0, this is plus 3. So this ion has been reduced to its ion component, okay, or its ion equivalent, which is ion 3 plus. You can also have ion 2 plus, but here we have ion 3 plus. Okay, so in terms of ion, this is not balanced. So to neutralize this, all I need to do is to add 3 moles of electron. Now here also, to neutralize this one, what do I need to do? You introduce 2 moles of electron also. Okay, this one, this one carries 0 charges, so you don't need to put that 0 there, just indicated so that you're able to see. So if you balance this, you notice that plus 3 minus 3 will give you 0. Plus 2 minus 2 will give you 0, so it's balanced. Then you now combine the two and try to see. So you combine this. So we have this plus this, copper 2 plus 2 moles of electron. Then the other side, the other side, you combine it. We have ion 3 plus 3 moles of electron plus this copper. So you combine these two at the right hand side, you combine this at the product side. Now, we now try to see how we are going to, you see now, you can carry this. I want my electronic charge to be in one place. It's appearing here, it's also appearing here. That's duplication. It can be combined. You either bring it here, it will turn to minus 3e, or you take that one there, it will turn to minus 2. So whichever way. So in this case, I want to take this to the other side. So I have ion plus copper 2 ion. Then this one is going to the other side. So what it will give me will be ion 3 plus this copper. Then the ion, I'm already having this one here already, 3e minus. Then I'm taking this to the other side. That will be to turn to minus. Don't forget, once it crosses this, the sign changes to minus 2e minus. Now look at that. I'm going to conclude this here. Let's try to fine tune it. That will be ion plus C2 plus giving us this 3 plus, okay, plus copper elements. Now, these are in the same basic term. Plus 3 minus 2, that is plus 1, that is plus E minus. I don't need to put 1 there. We already know that the 1 is existing there. If you check this now, at this reactant side, this is 0 plus 2. Now, let's look at it at the polar side. We have plus 3 here, minus 1. Now, what is plus 3 minus 1? 3 minus 1, that is plus 2. So, 0 plus 2 plus 2. So, it's balanced. Plus 2 plus 2. Plus 2 at the reactant side, plus 2 at the product side. It means the equation is balanced. So, I have the following for you to attempt. You balance the following just in the same way I've done it here. Then, there's a fun equation. You remember we have done in our part 2 of this series of balancing chemical equation, we did the combustion of organic compound where we made mention of hydrocarbon. Now, it is not only hydrocarbon that follow that pattern of balancing. Even other organic compounds like phenol, glucose, ethanol, sugar, and benzene. When we say substances combust, for example, it means they react with oxygen to produce what? Carbon dioxide and water. This go for all this. okay, for the remaining one, because they are all organic substances. So once they burn, they give you carbon dioxide and water. So you need to balance it. I will advise you search for my production on how to balance organic equation and follow the process I've given to you. You get it right. Please, I want to encourage you to connect to this particular channel at TSP STEM Resources. Share the videos with your friends and try to support us for the continuation of this production. Thank you very much.
I don't die on this one.